Hello everyone, we are the Weak Roads group. I'm Boyang. This project is to identify the traffic cache from the installed sensor, which will enable Weak Roads to take proper action quickly. After identifying such events, Weak Roads Accident Response Service can clear accident and help maintain traffic flow. The Victoria Government Organization Weak Roads provides the dataset we are using. The data is highly confidential and contained all of the detector's information on one part of Melbourne M1 highway close to Monash.
The dataset that we have been provided by Weak Roads consists of the following data. The masked incident file, which contains all the recorded incidents belonging to different groups and their spatial and time details. The detector ID file, which contains all the ADA detector IDs and their corresponding spatial information. And finally, the 20-second SVO data, which is actually a series of data for different dates, which contains all the various recorded measures from the detectors for a period of 20 seconds. We also have the different incident groups, which have been classified by the Weak Roads, which ranges from 100 to 500. We got like different unexpected vehicle behavior, unexpected hazardous objects, undecided traffic conditions, and others. The main dataset that we are using is the 20-second speed, volume, and occupancy dataset. It contains data for approximately 3 months and contains the 4 main measures that we'll be using to plot and detect accidents on the freeway. So the first one is the speed sum, which is the total of the sum of all the speeds of the passing traffic for a given period of time. The next is the volume, which is actually the density of traffic at the given period of time. And then the occupancy, which is the amount of time the detector is occupied for the 20-second window, which is the percentage. And then finally the speed observations. It's essentially the same as volume, but can be different in some cases where the vehicle speed may not be recorded due to some error by the detector. So our main goal here is to identify accidents along the major freeways and also to differentiate between a normal traffic buildup and an actual incident, so that it's easier for the IRS to send appropriate service response. So the idea that we're currently working with is creating heat maps and time series plots for the various measures, speed, volume, occupancy, and speed observations, as we have discussed previously. From plotting, we can observe patterns which are then recorded and compared with other patterns so that the incidents can be distinguished, so that an easy differentiation is possible. Let's start with heat plots. So this is an incident of type 100, subclass 101, recorded for 7:55 am and 9:12 am. On the y-axis, we have the recording data sorted spatially, and on the x-axis, we have the time. The measure is the occupancy. So you can see the plots for all the 5 lanes along the freeway, and we can see that each one is different. We can almost see a pattern on lane 5. Let's move on to time series plots next. So this is the incident of the same type and the same subclass for the same time as well. So both of these are the same incident, but the plots are just different. On the y-axis, we have the traffic volume, and on the x-axis, we have the time again. The legend, we have the recording detector sorted spatially, but here the measure is the volume. So we can see that lane 5 is almost different from all the other lanes, indicating that the accident has happened only on lane 5. This is the way I identify patterns from these type of plots. As for the steps, the same plots are then done again for various other accidents belonging to different groups for different dates. When enough plots are done, patterns can then be inferred among the different types of incidents, and then in future can be used to differentiate between incidents and normal traffic buildup. This can help the IRS to be prepared and respond appropriately. Thank you for watching.